Welcome to Cloudy with a Chance of Trust, a podcast for digital transformation leaders where we discuss the latest cyber attack issues, enterprise security strategies, and current security events so that you can successfully accelerate network and security transformation. And now, here's what's on our mind this week.
Welcome back, everyone, to Cloudy with a Chance of Trust, podcast by Pam and my counterpart here,
Lisa Lorenzen.
You all know us, and we're so glad to have you back. Today, we actually have a special guest, Nathan Howe, who is the VP of Emerging Technologies here at Zscaler, is focused in 5G. And we thought with everything going on and all the chatter about 5G, we would invite Nathan to come and talk to us from a perspective of 5G and how he sees the 5G world evolving. So with that, let's just jump in here. So Nathan, again, there's so much chatter and conversation around 5G starting to be deployed globally in 2019 and all that. And so many are touting that it's going to transform our lives with faster download speeds, low latency, more capacity. Is this right? Is this how you're seeing 5G affect all of us?
Yeah, and first, Pam, let me say thank you to you and Lisa having me. I'm actually kind of the privileged one to be here with you two. But coming into the kind of idea of 5G and the impact it will have, we need to look at it in terms of it's not just a new network that we're connecting our phones to download a YouTube video or whatever we're going to be doing with it, although that is the current way in which we see it. And it is being sold as a mechanism for consumers to enjoy the internet faster. And that is very much part of it, but it's definitely not the goal of it. And I think we need to keep the larger scope in mind. So you mentioned things around faster download speeds, which has multiple parts to play. It has low latency, again, multiple parts to play. And I think if we look at the entirety of what 5G really is going to be about, there's three main areas, and I'll cover all three very briefly and then dive into some of the specifics. So there's speed, as you mentioned, Pam. Speed is definitely about how the end consumer will consume whatever that service will be. And we are very much thinking about today's technology, as in, I said YouTube, or it could be Airbnb or something, but we need to open up our minds to the future things, and I'll come back to that in a second. The second thing is live. So we need to think about how quickly we need to interact with services. Again, not speed as in I need to fast download, but how quickly do I need to get a response from that service? Think about things like augmented reality, virtual reality. As those things become more and more part of the world we live in, they need to be low latency response times. And that's a big shift that's going to bring a change in the way in which we've done computing previously. And the final thing about the third point I'd like to make is around density. So we need to think about how technology is being consumed today. And 5G is taking a lot of that idea of where we'd have a lot of capacity in one location. And we're actually, if you think about a stack of servers, for example, having cables running out of them going into a switch and off to the internet. What we're talking about here is actually the idea of density of more and more devices, not just servers, but also end user devices, IoT devices, all of those things, all connecting, all within a very small radius, all at a very high speed. And so those three things, the speed, the live nature, and the density of it actually is much more than just faster end user consumption of YouTube or Facebook or whatever. There's a much larger set of implications there. And I'm happy to dive into any of those, but I'll pause for a second and see where we go with that.
There's a particular direction that I'd like to take this, which is IoT, and especially OT as well, industrial control systems. There's a lot of human-driven use cases, but there are also a lot of machine-driven use cases. And frankly, they have a need for better security as well as a need for better connectivity. How does 5G apply in those environments?
It's a very good question, Lisa. And I think because the thing is we're moving away from, we've been moving towards over the last few years, the device is connecting now. And if you think about it, a really good indication that kind of hit everybody a year or two ago, just before the pandemic, was the influx of smart scooters on every corner. And they're all connected, not necessarily to 5G, but they're all connected via a mobile connection, a mobile phone connection, or you might say in the US, a cellular connection. That differential or that need for that connectivity is not just going to be limited to those things. You have to think about, as you mentioned, IoT and OT. So you're going to have sets of controllers and sensors everywhere as part of smart cities and smart buildings that need to communicate. Yes, you could connect them back to a traditional network. Absolutely. You could go and build a high-speed building network. But what is going to be more and more, and what we're seeing being driven is that, well, I don't need to go and do that. Why do I need to go and have a physical cable connecting my IoT device when I can just utilize my radio access network to connect to 4G, 5G, and have multiple failovers that I could connect to various vendors or various providers. And actually, one of the biggest things we see in that space is the drive for private 5G. So let me just dive into that hole for a second. Private 5G itself is something that is not a current idea. Private 4G is not something a business like a food company or an energy company doesn't go and build a 4G network. They build a Wi-Fi network. And 5G networks and private 5G networks are going to replace a lot of those, what we consider local networks managed by an enterprise. And the big advantage of that is that devices that connect to the 5G network that's private can also connect to the 5G network that is public. And that allows a kind of a very simple way of falling over or failing over to another network. But private 5G also allows enterprises to provide their own set of controls, their own set of restrictions as well. But the biggest piece of both the private 5G and the public 5G in relation to IoT and OT is, well, it's just another network for them, really. It just becomes another network. The key here is actually something that's very new to the idea of 5G. So let me just explain that for a second. 4G, traditionally in the LTE world, we would have most of the compute, as in the resources being consumed, would either be within the packet core at the telco or externally at a hyperscaler, your data center at Zscaler, for example, where we're outside the walls of the telco. But now the evolution is we're now moving with 5G, they're bringing in a thing called multi-access edge compute, or MEC, or MEC, as we often say in the industry. And so MECs are actually an evolution of that cloud compute that once existed, maybe in your AWS colo or something, but now moving into the edge closer and closer and closer to the end consumable device. And that edge is an orchestrated set of services. Could be firewalling, it could be augmented reality, it could be DNS, it could be anything, but it could be anything that's going to serve the set of users consuming that radio access network near that. And if you think about what that means in terms of delivering a service for IoT or OT, you could actually have everything connected to your own private 5G, running your own controls within your own mobile edge compute, all within one box, and having a radio mast on top that connects them all. And you can actually see this scenario being more and more prevalent. And we have seen this already with some of our customers in places like smart warehouses or pop-up logistics locations or whatever it might be. So that is definitely becoming more of the norm. But to come back to your original question, it's a long story to get back to what you asked, Lisa, which was around OT and IoT, is that it's another network, it's another means of connectivity, and there's another set of compute services at the edge. So we have to consider another set of attack surface, and we have to consider another set of controls, or we go and be smart about it and maybe leverage an overlay on top of that network like we do with other networks and control it through the overlay. So that's where we're seeing the world go today.
That makes a lot of sense for IoT. And I would imagine that there are also other use cases that get similar benefits from edge compute. Where else does that play a role?
It's huge. Edge is becoming such a big part of this whole conversation. And I just asked the listeners to go and look in the news around what the hyperscalers are doing. So the Amazons, the Googles, the Microsofts of the world. You would have seen the announcement a couple of weeks ago from AT&T with their partnerships with Google and Microsoft, or Verizon with AWS. And that has a major infrastructure shift. If you're thinking about it now, today, when you want to consume a service, let's just use Amazon as an example. If you wanted to consume an AWS service, your device, be it a phone or IoT or OT device, will have to move through their mobile edge compute, if it's a 5G infrastructure, through the packet core, egress to the internet, and go out to the internet to AWS to get that service. Now, it's not slow, but it's not going to give you that live under 5 millisecond response time that is required for these sort of services. And so to your point, when you look at the low latency stuff, we need to have the compute and also the orchestration very close. And that's where Amazon and Microsoft and Google are moving their orchestration and their workloads into those edge compute services. So you can have things like autonomous driving or drones or trains at high speed connected, all these things. And the idea is to make, if you look at it in a kind of a utopian kind of idea, it's very much the ubiquitous connectivity. You end users shouldn't know, you just consume and your devices just consume, but all of the controls get stacked up in an orchestrated model at the back end, primarily the edge, maybe at the back end, and at various locations where those compute services are required.
Nate, that makes so much sense. In my former role, we looked at deploying wireless routers, whether it was a backup or if we had a small location or so forth. But there were so many dependencies relative to really the location of the facility. Was there a tower near, or was the facility penetrable? With 5G, do those dependencies change, or is that where you start to talk more about moving to a private 5G network?
Great question, because it is the question that enterprises are going to have to ask themselves is how much do they want to be responsible and how much do they want to dive in and control this versus leveraging a service model. And we're going to see new industries standing up around the space. So new edge platforms, how they're going to be delivering that last mile for connectivity. We see that already in some places where companies are delivering like small boxes, like you mentioned, that are maybe Wi-Fi enabled on one side to connect devices that are not 5G enabled, and then having a 5G SIM as an upload, as an upstream to the service provider. So kind of the inverse on what we would consider the future connectivity. But it's what's happening today because not everybody has a SIM or a radio signal that can actually talk 5G. So there's that. I would say that model's happening. We're going to see definitely an uptick of new applications that we didn't expect at the edge and will require those form factors to run. Think of it like like buses or police vehicles or those sort of things that today require high-speed connectivity, but have not previously had the sort of network infrastructure to provide it to them. Maybe that I do see that being something as well. But I also see there being an influx of new applications that we haven't considered yet. And I mentioned it a bit earlier. We're talking very much about what we know today. But if we go back 10 years ago, there was no Uber, there was no Airbnb. When 4G came about, it enabled these services to grow naturally, organically, and leverage these almost live services to build new industries. And that whole online consumable market on 4G grew. So 5G is not only going to provide us software and applications that we couldn't think of, we're also going to see things like new hardware models that are maybe, as we see today, like eSIMs. That's a good example for you. Is eSIM is now, if you think about SIM cards used to be a physical device. Now they're rewritable. They're a chip that can easily be rewritten. And I urge everybody to go on. There's a great piece from Telecom in the USA or T-Mobile in the USA, where they're actually allowing customers to run an application on their iOS phone to rewrite their SIM card to connect to T-Mobile for a period of time to test it out. That's crazy. You couldn't have done that before. Previously, you had to switch out a SIM card. Now you can do that. That's amazing. So we're just in the infancy of where it's going.
Absolutely. All of this new functionality must come as a price. I've heard people say that 5G will reduce costs, but it sounds like there's a lot of infrastructure upgrades and, frankly, a lot of rethinking of how we carry applications. So what do you think about sort of the cost benefit model here?
As with any new technology, there's definitely going to be a lot of borders and boundaries to entry as we go along. Today, everyone can buy a 5G phone. They are at the high end. So of course, at the high end of the phone market right now, because it's a value add. As that becomes more and more ubiquitous, obviously that'll change. The biggest part of 5G that will shift is that today, the back-end infrastructure. So if you have a 5G phone, it's very unlikely that when you get a 5G connection, that you're connecting to a back-end 5G mobile edge or core. You're probably still leveraging the older cores. And that will change. Don't get me wrong. All the enterprises that are changing this, the T-Mobiles, the Verizons, the Deutsche Telecoms, they're all changing that. But it's not ubiquitous yet. So there's obviously a cost implication that will be knocked on to the end consumer. I do also see that as it becomes more and more ubiquitous, the price will come down, but also as the use cases become more and more powerful. The idea of, and I'd like to come back to one I talked about with a German industry about the idea of having 5G in high-speed trains. So that 5G link is not just meant to be a one link for everyone browsing YouTube. It's going to be broken up into various, what they call slices. And so that's a whole other topic of discussion. But ultimately, slices, think of them like MPLS tags in the good old networking world. You assign a tag to different traffic and it gets guaranteed SLAs around that. So you'd have maybe 3 slices, one for end users to watch their YouTube videos. So that doesn't need to have low latency. That can have a mid-range latency, high speed to download the packets and watch the videos. Then you might need to have a telemetry system. So telemetry feedback of the train going back to wherever. And that itself will need very low latency, but also it's not a lot of bandwidth. And it has to have a guaranteed response time. And then the final slice would be something like drones. So one thing that no one thinks about is that trains is something that we see a lot in Europe of is as people go along the train tracks, they have to make sure that the tracks are cleared. And right now, that's a manual process. Humans have to drive along next to the train track, get out every few hundred meters and look around and see if they can see anything. But what about drones? So you fly a drone ahead of a train that is connected to a wireless for a 5G network that's sharing information back whether the track is clear or not. At the same time, because those drones are flying at a certain level, they can see other geological things around them. So they're actually able to provide other data sets back to another resource. So this brings me into the point of information sharing and possibly passing on that cost of the consumption of 5G, of the development of 5G, because you can actually collect more information than you need for your specific scenario and you can on-sell it. So yes, cost is going to be a challenge, as with anything new, but this is where we're going to be going. And one of the things that's kind of cool here is that the infrastructure we're building now with 5G, not the radio and not the handhelds you're consuming right now, but the infrastructure, the back end, the core, the mobile edge, that's going to be there for 6G, 7G, 8G. It's revolutionizing the way in which compute will be done. And that means all sorts of cool things that happen whenever I'm dead and someone else is doing this.
Our children will do things that we can only dream of.
Right, exactly.
So Nate, you had some really cool examples there, like with the drones and all that, but I always go back to the example of IP telephony. IP telephony was around for a really long time, but based on how people started transitioning to it and starting to go ahead and use and change their thought process around the technology. With 5G, do you think this will be a quick to embrace? And when people start to embrace it, do you foresee it to be more special use cases? Because really, does the everyday user need 5G? Or is it really going to be something that's going to be, to start out, more pocketed in special use cases? Because the back end, to your point, is not all going to be there day one, right?
Right.
Am I looking at this the right way?
Absolutely. And I do think that I personally, my 4G speeds are fast enough for what I'm doing. And that's like Zoom calls and whatever else. Like it works perfectly fine. But again, I'm also limiting myself to what I'm doing today. And I don't know what the future is going to bring. And that is kind of, if you go back 10 years to 3G, 10 years ago to 3G as we move to 4G, nobody foresaw that we would have Uber or we would have any of these live sharing information apps that we have today. No one foresaw Zoom or Teams. Think about what Skype was. It was a clunky thing on a Windows box and whatever else. And this is where we're going to see people pushing the boundary now. And I think that, to your point, Pam, 5G today is great. Like, if you get it if you're in the right area and you have the signal connection, fantastic. You can download a movie in split seconds and that's fantastic. To me and you, that's cool. But to the industry, what that means in the future, that's nothing. Like that street corner, okay, it's a blip. But in the future, as we get more and more of those locations and more of that bandwidth available to people and to devices, and we can move very seamlessly from one to the other, an autonomous car doesn't need to worry about storing data. It can automatically speak back and get live updates as it drives around the country, wherever. That's where things will drive things. It's a bad kind of analogy, drive, when I'm talking about cars. But the key here is thinking about where we're going to be going. And I think that's, to your point, today, maybe there's somebody out there saying, I really want to do my augmented reality or my virtual reality on the go, or they don't want to have a home network or do wireless anymore. There's definitely, those sort of people are going to be pushing the edge of where we are. I would say that the niches right now, the corner of the pocket cases we are seeing is certainly around the idea of augmented and virtual reality in industry. So you've probably everyone heard about the Microsoft sold I think 100,000 plus HoloLenses to the US government. Again, that's purely because of that virtualized or augmented reality that'll be leveraged for connectivity. And that will be either over a traditional network or it will be over a 5G network. And I think 5G will allow them greater mobility, allow them to do things in more places where you can't run a cable. You can't run a cable to a plane in the middle of the desert. Maybe you can get a 5G signal instead. Like that's where I think we're going to see that uptake drive new industries. So I don't think it's just a matter of, is it going to be a cost thing? Is it going to be consumed today by end users? Yeah, it will be. But the people who are looking at this with fresh eyes and going, what can I build and how can I do that? That's the ones that are going to change the industry. And hey, in 2031, let's get together and have a chat about 10G and see what happens then,
Definitely. Thank you, Nate. This has just been a fascinating conversation. And I know this is a fast-moving topic. So as 5G progresses, we'd love to have you come back and maybe discuss further, drilling in detail on some of these use cases, et cetera. And for folks who are interested in learning more, At our recent Zenith Live user conference, we had a session on 5G and zero trust and the power of that for security use cases. You can go to zenithlive2021.com and review that breakout session. All of that content is available on demand. We also have some great resources on our primary website, zscaler.com. So however you choose to explore this, I hope that you will come back to join us for future conversations and maybe hear more about what Nate has to say about this. So Nate, we'd love to have you back sometime.
Be very happy to join you.
Great. We'll look forward to talking to you again soon. Thanks for listening to Cloudy with a Chance of Trust. Check back with your podcast provider regularly for more episodes. You can find Lisa Lorenzen and Pam Kubiatowski on the CXO Revolutionaries website at revolutionaries.zscaler.com or on LinkedIn. Statements by Zscaler podcasters and guests are informational only and should never be construed as legal advice. You should consult with your legal advisor on matters related to you or your business. Zscaler makes no warranties, express, implied, or statutory as to the content of this podcast, and it is provided as is. Content on this podcast may contain forward-looking statements that are current as of the date of recording and subject to change. These statements are subject to the safe harbor provisions created by the Private Securities Litigation Reform Act of 1995. Full legal disclaimers are available at revolutionaries.zscaler.com. Copyright 2021.